Hey, well, welcome back. It should be, I guess, Thursday, is it? Yeah, 9:33 on Thursday. Well, I wanted to review a little bit about what we learned in our Introduction to Geometry, one of my favorite maths. First off, we learned about what a line is. A line has no beginning or ending, which reminds me of what? Reminds me of God. He has no beginning or ending. We talk about a ray, which has a beginning, called the endpoint, believe it or not, and it goes on forever, which reminds me of what? People. Yes. Segment, we learned it has a beginning and an ending. Reminds me of animals. And a point. Now, I want to make sure you are naming these correctly, saying them, but also writing the right symbol above them. Please review that with you on your own. We learned about a plane, about parallel lines and the symbols to show they're parallel, and about intersecting lines and identifying them. Then, we went to yesterday about angles, not angels, angles. And we learned about angles, how they're two rays with the same endpoint to form an angle. We learned three ways to name an angle. This is angle PQR, or angle RQP, or angle Q, right? Three ways to name it. Then we learned about a protractor. And a protractor, we learned, is a very handy half circle with 180 degrees that's used to measure and to draw angles. So we learned about the inside scale and the outside scale. And yesterday's class, I just used the inside scale every time. But sometimes the outside scale comes in handy. All right, so we learned about how to measure angles by using your protractor. Here I have the ray that starts going that way. I put the notch, the vertex notch, on the vertex, and I pointed the ray at 0 on the inside scale, and I read it up to 120 degrees on the inside scale. On this one, I put vertex E in the notch. I line up the ray going across the board here. I line that up on 0 on the inside scale, and I counted up to 40. So the measure of angle DEF is 40. When it came to draw angles, I first just drew a random ray. Then I used that, the beginning point of that ray, the end point of that ray as my vertex. And then I measured on the inside scale 70 degrees. I put a point there, took off my protractor and connected the points and made another ray. That's a 70-degree angle. I did the same thing with a 145-degree angle. Then we talked about estimating measures for angles, and you worked on that on your practice. Today, we're going to classify angels. You know, there are the angels that are very, very powerful. We call them archangels. Now, no, that's not what we're talking about today. Okay, classifying angels is not dealing with this is classifying angles. Page 465. If you follow along with me in your book, page 465. And you can see the same thing I'm talking about there. You can always go to ClassZone.com. They're not nearly as pretty as I am there, but they will be able to explain the same kind of things for 9.3 that I'm talking about today. There are a lot of ways you can watch this video over and over, and a lot of ways that you can get this. So work on that. Now we're talking about classifying. You know, classifying, when I put spoons in the spoon part of the utensils, and I put forks in the fork part and knives in the knife part, I'm just classifying them. In other words, they have similarities. The spoons all look like spoons, forks look like forks, knives look like knives. So classifying is not a difficult process. And when it comes to angles, mathematicians have noticed that there are certain angles that you can give names to, and they all are within that group. For instance, angles are classified by their measures. There's the right angle. All the others, I'm sure this one is very proud, all the others are wrong. This is the right angle. It has a measure of 90 degrees. Now, in order to show, if I measure this on a protractor, it would be 90 degrees, in other words, a square corner. In order to show this is a right angle, I put this red box there, or part of a red box. And again, use red, right? As we did with the parallel line little arrows. Use red to show when you draw an angle that it's a right angle by putting that little box there. Then we have acute angles. Now, they have measures that are less than 90. So a 2-degree angle is an acute angle. It's very acute. I mean, just think how small and adorable a acute angle would be if it were only 2-degree measure, just starting out in life. No, actually, acute angle is less than 90 degrees of an 89-degree angle, right? That's pretty close to 90 degrees. Almost a right angle, but an 89-degree angle also is an acute angle in the sense that it's less than 90 degrees. Then we have what are called obtuse angles. Now, obtuse, that even sounds big, with obtuse. Obtuse. Acute, very tiny. Obtuse, very big. Well, obtuse angles are more than 90 degrees. So you can go all the way from 91 all the way up to 179 degrees. And those are all obtuse angles. They just measure more than 90. So here's an example. If this were 90 degrees, I would have a ray coming up just about there in the square corner. You can say it's more than that. It's more than 90 degrees. So it's an obtuse angle. And then they classify what they call straight angles. Now this sounds impossible. How can you have a straight angle? I mean, it's kind of like having a civil war, or it's kind of like having jumbo shrimp. I mean, how can you have that? They just sound opposite. Straight angle? Yeah, they do. In geometry, it's called a straight angle. Here's the vertex, all right? And instead, if you were to measure this angle, guess how many degrees you would have? That's right, 180. So a straight angle is an angle. It's not a line. We don't call it a line because it has a vertex right here. And that is a straight angle of measure 180 degrees. All right, how about classify these angles with me? Let's put the letters up in the right spot. Okay, let's start with angle C. We're going to start with angle C. Which one is that? Right angle, where it's 90 degrees? Is it an acute angle, less than 90? Is it an obtuse angle, more than 90? Or is it a straight angle of 180 degrees? I'm looking at angle C, right here, angle C. What do you think? I agree with you. It looks obtuse to me too. All right. If it were 90 degrees, I would think there would be that line, that ray coming up straight like that. But it's more than 90 degrees. So I'm going to put an A here. I'm sorry, a C right here. Because angle C is obtuse angle. Okay, let's go to angle D. What do you think angle D would be? Of classifying those. Well, I'm looking at that and I'm thinking this angle measure in here, it looks less than 90. If it were 90 degrees, I imagine there would be something coming off here and it would look like that. And it's less than 90 degrees. So that's right, it would be an acute angle. Don't you want to just give it a little pet there? It's so cute, right? Acute angle. How about angle A? This is probably the hardest of these four angles. Angle A. All right, I think I agree with you. Yes, I think I agree with the boys there. All right? Yes, boys, that's pretty good. Here we go. Angle A. This is how this goes. It's more than 90. Not much more, but it looks like it's more than 90. If it were 90 degrees, this side of that would be coming right off like that. But this angle right here is more than that. It's more than 90 degrees. So I would call that another obtuse angle. Now, angle B is really easy in that. What is angle B? Well, I got the symbol there for you. What does that mean? It means it's a right angle. So we would say angle B is a right angle. Any questions? Raise your hands. I'm sorry, I can't see your hands. Anyway, now, besides that, it already smells bad enough in there. Put your hand down. Now, there are a couple other angles. Now, we're moving from what would be, well, I've heard all this before and I know it all. Well, I'm sure this is just an introductory this week and we're going to get more detailed in geometry, but these are very basic things. But what I'm talking about next, I'm going to give you a challenge. And if you can message me with the answer, then I will do something. I don't know what, but I'll do something. First off, let's talk about these. Vertical angles. Vertical angles. Now, you know, this is kind of like scissors. You know how scissors, they kind of come together and they make, you know, like an X, but you can go like this. You go scissors. That's fine, huh? Yeah, okay. Vertical angles are when lines intersect each other, like these two lines up here, and the vertical angles are the angles opposite each other. Not next to each other necessarily, they're opposite each other. So I would say angle 1 and angle 2 are opposite each other. These are intersecting lines. And these are called vertical angles. Angles 1 and angle 2 are vertical angles. Angle 3 and angle 4 are vertical angles. They're opposite each other. And because of that, there are two pairs of vertical angles every time lines intersect each other. All right? The ones that are opposite each other are vertical. Now here's the real key, all right? Vertical angles are equal in measure. Always. All right? So I have angle 1 and angle 2 as being vertical angles. Whatever their measures are, they're equal. Angles 3 and angle 4 are vertical angles. Whatever 3 is, 4 is. Whatever 4 is, 3 is. All the time. With intersecting lines. That's pretty cool. These vertical angles are special. And you can do something that you don't need a protractor. You can do something. That's going to be the challenge in just a moment. Okay, let me just ask you, see if you got what I just said. Let's suppose angle 1 is 110 degrees. What's angle 2? 110 degrees. Da, da, dum. All right, so whatever angle 1 is, angle 2 is. Whatever angle 2 is, angle 1 is. When you have lines that intersect, the angles opposite each other are called vertical angles. Now, we have to get to another kind of angle. I know, you probably heard of all these. Right angles, obtuse, straight angles. Okay, that's old stuff. Well, vertical angles, these next are called complementary angles. Complementary angles. You know, when we talk about complements in language, in direct objects, indirect objects, predicate, knowledge, yes, they complete, right? That's what complement means. It's something that completes. So in complementary angles, if you have a right angle and you divide it with another ray, in other words, here's a right angle. I drew the box there to show you that, that is a right angle. But I started that same vertex and I drew another ray. Well, I divided the right angle into 2 angles, right? Angle 5 and angle 6, all right? So guess what angle 5 and angle 6 will add up to? Right? They have to add up to 90 degrees. Because a right angle is, what? 90 degrees. Therefore, angles 5 and angle 6 have to add up to 90. They're called complementary angles. Now, there's another word, complement, that isn't spelled the same way, and it's just Mr. Frazier's way of helping you remember what complementary angles are. If I say I compliment you, in the other way, it means I say something nice about you. Let's suppose you live to be 90, all right? I would compliment you. Wow, you live to be 90 years old. Compliment you. I compliment you. You live to be 90. That's my silly way of trying to remember that complementary, PLE, angles add up to what? 90. They add up to 90 degrees. Okay, so let me ask you this thing. Knowing this, if an angle, the measure of angle 5 and the measure of angle 6 equal 90 degrees, right? They're complementary angles. I took a right angle, divided it into 2 angles. All right? So measure of angle 5, if I tell you this is 50 degrees here, in that angle, what is angle 6? Well, if you said 40 degrees, you were right. How did you know that? Well, that's not hard, is it? 50 plus 40 equals what? 90. So if you know the measure of one of a pair of complementary angles, you can figure out what the measure of the other is. By the way, you'll have to do that in your practice today. All right, now I have one more kind of angles for today. Supplementary angles. Now, supplementary angles are angles that are formed if you have a straight angle. Remember I told you what a straight angle is? It looks like a line, but it has a vertex. And what is the measure of a straight angle? 180 degrees. Well, if off of that vertex I draw another ray, any place, all right? If I just draw that ray facing any way, I've divided the straight angle into 2 angles, correct? Well, that's what I did here. I divided a straight angle by drawing another ray off of the vertex, and now I have angle 8 and angle 9. And guess what they add up to? Right. They'll have to add up to 180, because a straight angle is 180 degrees on the protractor. Well, if I divide this into 2 angles, they'll have to add up to 180. Let's see if you can figure this out then. If angle 8 and angle 9 add up to 180 degrees, and I tell you the measure of angle 8 is 110 degrees, what is the measure of angle 9? And you don't have to use your protractor. No, don't get this out. You don't need this. You don't have to put it here and let me measure angle 9. You don't have to do that. Because I'm telling you a shortcut, right? You know if these angles are supplementary, they add up to 180. If one is 110, what's the other one? Well, then I would say it has to be 70 degrees. How many agree, right? No, I can't see that anyway. All right, because why? What's 110 plus 70? 180. All right, and if I divide it up 180 degrees into 2 angles, those 2 angles better add up to 180. And if you know one, you can know the other. No protractor needed. Here's the challenge. I'm going to close with this. Today's lesson. And by the way, you look at what we're doing tomorrow. It's kind of a review. I don't have a YouTube video for tomorrow's lesson, Friday's lesson. But you can just review as it says in the assignment. All right, here's the challenge. We're talking about vertical angles. I told you angle 1 is 110 degrees. With just knowing that, no protractors used at all. It's illegal to use a protractor to give me the answers to this. But will you message me? If angle 1 is 110, what's the angle 2? I already kind of told you that. What's the measure of angle 2? What's the measure of angle 3? What's the measure of angle 4? I have told you enough. And you can watch this over and over again. The key is what we just talked about, the complementary and supplementary angles. Using that information, you can tell me if you know one of these angles in lines that intersect, you know it all 4, or you can figure out all the other 3 angles. Will you message me what you found out? And here's how you will write it. And if angle 1 equals 110, put measure of angle 2 equals measure of angle 3 equals measure of angle 4 equals. I'd love to see how many of you can figure that out. Bye-bye, y'all.